So we have been given two differentiable functions, f and g, and with some table of values. We don't have the formulas, we have just some values. Now the question says use the different rules to find the derivatives of given functions. Here, first one is derivative of hx, which is quotient of two different things. I don't know what are f and g, but I know that if I want to find the derivative of h, I need to use the quotient rule. So derivative of gx plus e, numerator, times the denominator minus the numerator itself times the derivative of the denominator. Then the denominator squared. Okay. From this, you right away see that, okay, let me just continue here. Derivative of the numerator, gx plus e, that will give me g prime x. Derivative of e is just constant. Derivative of constant is 0. So g prime plus 0 is just g prime times fx plus x squared minus gx plus e times derivative of fx plus x squared. So it will be f prime x plus derivative of x squared is 2x. And then we have fx plus x squared squared. Now, knowing that the derivative of h is that, I can use it to find h prime at 2. So that will give me g prime at 2 times f at 2 plus 2 squared minus g at 2 plus e times f prime at 2 plus 2 times 2 over f of 2 plus 2 squared to the power 2. Now, take all the numbers you see from there. Oops. I'll put a little bit upper there. And then from there, I can see that this is g prime at 2. G prime at 2 is 2 times f at 2. F at 2 is 4 plus 4 squared, 2 squared is 4 minus g at 2, the function itself at 2 is 3 plus e, and f prime at 2 is 0 plus 4 over f at 2 is 4 plus x squared, 2 squared. Well, you do multiply all those things, you will get a number there. What is that number? So let me see. This is 8 times 2 is 16. 16, then there is minus 12 here. That will give me plus 4 minus 4e over, this is, oh, there's a square there. This is 4 plus 4, 8, 64. And that's the number that we were looking for. Okay. How about FOG? Well, h prime x is going to be the derivative of inner one times the derivative of outer one evaluated at the inner one. And when you set x equal to 2, then we have g prime at 2 times f prime at g of 2. G prime at 2 is already 2, I know that. f prime, I need to know what is g at 2. G at 2 is 3. And now f prime at 3, f prime at 3 is 1. So I have 2 times 1, which is 2. How about this one? If h is that, h prime x is going to be h prime x is going to be, well, the composition of two functions, derivative of inner one. In this case, the inner one and outer one are the same thing. So f prime at x times f prime, but evaluated at the inner one, plus product rule, 2x sine of pi x plus x squared, derivative of sine pi x. If it was sine of x, I knew what to do. That's the cosine x. Now this is sine of some function of x. But that function, which is now, it's called the inner one, you have to find the derivative of that. Pi times x, the derivative is pi. Like 2 times x is the derivative of 2 times x is 2. 3 times x is 3. Pi times x is pi. The derivative is pi. So this is pi times cosine pi x. And now let x to be 4. So we are looking at f prime 4, f prime at f of 4 plus 2 times 4 is 8 sine of 4 pi plus 4 squared is 16 pi cosine of 4 pi. And from here, now f prime at 4, f prime at 4 is negative 5. F at 4 is 2. 8. What is sine of 4 pi? Okay, I know that 4 pi means that you go around the circle twice and you come back and hit the 0 angle. So sine of 4 pi is the same thing as sine of 0, which is 0. So this will be 0 here. 16 pi cosine of, okay, what is cosine of 4 pi? The same arguments. Cosine of 4 pi is the same thing on the circle, go around twice and come back to the 0. So this is cosine 0, which is 1. So please, 16 pi times 1. And now pick f prime at 2 from the table. It is 0. I got it from here, plus 0 plus 16 pi. And that will give me just 16 pi. So the different combinations and all those things, I will ask you to do this one yourself. Again, you need to apply the chain rule first. The inner one is 3 sine of pi over x. And then find the derivative of that multiplied by f prime at that point. So please try to do that one yourself. And I guess this was what we wanted to do for this set of examples.